Welcome everybody. Good morning, good afternoon, depending on where you are. Thank you very much for joining us on this webinar. My name is Kingsley Wood. I'm with the business development team here in Singapore at Amazon Web Services headquarters for APAC. The topic for today's webinar is what is new on AWS and what it means to you. We're going to assume that many of you are existing customers of AWS. So we're going to be talking about some of the recent enhancements and feature changes and improvements we've made to our services, as well as some of the new products and services we've released over the course of the last year. Some very exciting development there. So as we go through this presentation, it's going to be pretty detailed. We've got a lot of material to cover, as you can imagine. We're going to be taking about 45 to 50 minutes to cover the content of the presentation, and then if you want to hold your questions to the end, we'll try and answer some of those online and some of them verbally as well. Please also take the time to answer the survey that pops up at the end of the presentation, at the end of the webinar, and we'd be happy to send you $25 in AWS credits. Just to be clear, if you have an AWS account already, you can simply apply that credit code to your account for $25 in credits. If you don't have an AWS account yet, you'll need to create one, activate it, and then you'll be able to receive and use that $25 credit for yourself. Right, well, let's get started. The main topic of this webinar is really to illustrate all the new stuff that we've added to AWS over the last year. And what that really boils down to is talking about how we at Amazon Web Services are continually innovating on behalf of our customers. We're very excited about the pace at which we're innovating. This is tremendously interesting and exciting technology, and it's moving at an incredibly rapid rate. In fact, just over the last year, we've seen an addition of 168 features or new product and service enhancements that we've made. If you think about that in terms of how often that comes out, it's probably 2 to 3 announcement or feature announcements every single week. For those of you that are already Amazon Web Services customers, you'll be receiving some of our newsletters and updates through the email system that we use to alert people about that. And it's just amazing to see not only the rate of innovation, but also the increase in the rate of innovation that we've seen over the last few years that Amazon Web Services has been running. So let's talk a bit briefly, quickly about how we actually innovate. It's very important to us to listen carefully to our customers. So we're constantly gaining feedback, listening to what problems customers are having and things that we can do to improve their use cases and their use of our services. And that's how we really come about with a decision on what to actually focus on to improve our features and improve our services. As a result of listening to customers, we often realize that there are things that they are doing repeatedly which don't really add particular value to their business, but things that they would like us to do for them. And that gives us a lot of inspiration for some of the new services that we've added to help them achieve their IT goals more efficiently. You've heard an expression that we use pretty frequently called undifferentiated heavy lifting. And this constitutes the workloads that don't add particular value to the business, but a lot of customers we find are repeating again and again. So if we can take that headache away from customers, manage to do it for them on behalf of them with our new services and enhancements to our features, we can make them more efficient. As technology evolves as well, the hardware is constantly improving. So in conjunction with that, we're able to bring new technology and new hardware to make it available to customers in the cloud. And that takes the form of some of our new instance types, which I'll get into in a little bit more detail later. But you'll see that EC2 is constantly evolving in terms of the size and the structure and the capabilities of some of the instances that we're able to offer in our cloud. Now, one of the great benefits that you as a customer has of using Amazon Web Services is that as we grow bigger, as we get more efficient, we increase the automation and the efficiency with which we can run our own data centers. And we are able to pass that back to you in terms of cost reductions, which we're constantly making. So in fact, you get more out of our services for less as time goes by. When you pull all these things together, you'll realize that we're able to create tremendous amounts of solutions and taking away headaches in your IT use cases that we can actually bring to bear in the form of our products and services. So that just gives you an idea of where we're thinking in terms of our philosophy of increasing the value of Amazon Web Services to our many, many customers. And now we have hundreds and thousands of customers in over 190 countries around the world that are making use of these services all the time. So the first section that we'll go into is a listing of the enhancements and improvements that we've made to our services. All of these services have been around for more than a year, but we are now releasing new features and enhancements to them to make them even better. And if you're an existing customer using any of these services, we encourage you to go back and revisit your architecture to take advantage of some of these new enhancements and feature improvements. It's a really advisable thing as well to constantly be reconsidering your architecture in AWS. One of the benefits of using virtual infrastructure in the cloud is that there's no commitment to any particular architecture or structure of your uses of architecture or systems within your IT needs. And what this means is that you can constantly reevaluate, revisit the architecture, and fine-tune it, making it more efficient, reducing your costs, and more effective for your end customers. So let's get into some of the details now. First of all, those of you who are using Elastic Beanstalk will remember that when it was released, it was simply supporting Java. Just in the last year, we've added 4 new runtimes, PHP, .NET, Python, and Ruby, as well as the fact that we've increased the availability of that service to many new regions. So it's now available in the US West, in Europe, Singapore, and Australia. We've further improved the command line by using a simplified command line, which we call EB. We encourage you to look at the documentation on that. There's also the ability to do configuration enhancements. And what this means is that you can now specify declaratively how you want to install packages and libraries into your Elastic Beanstalk system. So you can actually use it to do the systems that you want to do without having to reconfigure an AMI and have that AMI built up as well. In addition to this, if you're ever a user of a database, you can now support RDS within Elastic Beanstalk, which is a great advantage. Again, reducing the hassle of actually running and maintaining a database within your system. With Beanstalk, you can simply tie into RDS, Relational Database Service. On the VPC side, we've improved the abilities that are available to you within VPC tremendously. First off, we've added the T1 Micro, our smallest instance type, so you can use that within VPC. We've also improved the ability to use different devices externally to connect with VPN to your VPC. If you're a user of a device that's not a BGP compatible device, you can now use all of those. We've tested our static routing options with all the typical devices from Cisco, Juniper, Yamaha, Netgear, Microsoft, etc. So if you have any of those typical non-BGP available devices, you can use them to connect to your VPC via VPN with one of those. In addition, we've improved our ability to propagate your route tables using VPN connection routes. This saves you a lot of time in having to duplicate that effort and can actually promote the ability for you to take your VPC route tables and promote them through your VPC. Just a little point there, for those of you that aren't familiar with VPC as a term, this basically extends your existing infrastructure and network into the cloud, meaning that you can augment your existing on-premises solution and network with additional instances and infrastructure in Amazon's cloud and make it appear as if it's on the same network. This gives a lot of flexibility in terms of adding additional capacity without having to move your entire infrastructure into the cloud right off the bat. Finally, I'll just add a point there about multiple IP addresses. We released a feature some time back called ENI, Elastic Network Interface, and this allows you to add multiple IP addresses to a single instance. When you can do this, you can actually use one of our biggest instances, the CC2 8 extra large instance, which allows you to add up to 8 Elastic Network Interfaces with 30 IP addresses each, bringing a total of 240 possible IP addresses to a single instance. A very powerful notion if you have that need in your particular use cases. In addition, VPC has added the ability to run all of these additional services now in VPC, meaning that it's become pretty much parity with regular Amazon Web Services. You can run all of these services inside of your VPC, again extending your network from your existing on-premises solution. Let's jump now to Relational Database Service and specify a little bit more about the details of how we've enhanced that service. It's grown tremendously over the last year. Some of the smaller things, for instance, we've increased the snapshot retention period from 8 days to 35 days. We've also added the ability to run multi-AZ, multi-availability zone option for Oracle. What this means for those of you that aren't familiar with this is that your main database, your master database, runs in one availability zone, one of our data centers, and then a second standby version, which is synchronously kept up to date, is run in the second availability zone. If anything goes wrong with the first availability zone, the traffic is immediately switched over to the second availability zone, giving you a fair amount of redundancy and backup of that existing database from the master. So the master and the standby can be switched very, very quickly like that. So now that we support that for MySQL as well as Oracle, we've also added RDS for Microsoft SQL Server. On the Oracle side, we allow you to now use the Oracle Enterprise Manager for 11G, and we've also added compatibility with Data Pump, which allows you tremendous amounts of flexibility in moving huge amounts of data from Oracle systems on premises or from RDS into another RDS system, or if you have an existing Oracle system running on EC2 and you now wish to take advantage of Relational Database Service of RDS, you can use Data Pump to move the data from your existing EC2 managed, self-managed instance of Oracle to a managed 11G database in Oracle using RDS. In addition, we've added the SQL Server Database Engine Tuning Advisor and agent support, which means that you can take advantage of some of the smarts that have been built into Microsoft SQL Server without having to know all the intricate details of how to actually manage your indices and so on. This gives a tremendous amount of ability for non-very technical database administrators to take advantage of the huge capabilities of some of these very complex databases. We added a free tier to RDS, meaning that in addition to your micro that you can run for a year for free in EC2, you can now run a micro version of either Oracle, MySQL, or SQL Server for a year on your system in your account without having to pay a cent, which is a really tremendous offer that you can test out the full range of AWS, including EC2 and RDS, for 750 hours per month, which basically translates into an instance, a micro instance of each running for a year. I'm going to talk a bit later about how we have now allowed the ability for you to promote read replicas. Read replicas are basically an additional copy of your database that can handle the offloading of some of the read traffic to your database. In addition to this, we've enhanced the ability for you to rename your endpoints. Now what this means in terms of a client that's accessing an RDS database is that if for some reason you wish to change to another RDS instance or you have some problems with the original RDS instance, you can simply rename the endpoint of your RDS instance, meaning that the client doesn't have to be reprogrammed or changed. So traffic can continue to flow from the client's perspective to an RDS instance that even though you might have moved it from one AZ to another or moved it from one version to another. Some of you that are tracking our progress with EBS will know about provisioned IOPS. This is basically an additional type or an enhanced type of EBS volumes, elastic block store volumes, that can now be used in your RDS instance to give you a much more reliable throughput on your IOPS for your RDS instance. All right, let's talk about CloudFront for a little bit. Our CloudFront is our content delivery network system. We've increased the size of the maximum size of the files that you can use from 5 gigabytes to 20 gigabytes. This is quite an astounding, huge size of file that can actually be downloaded. If you think about how big games and some of the software packages have become over recent years, it's pretty understandable that a lot of our customers would want this huge file size, and being able to make that available for distribution through CloudFront means that huge distributions of new updates or new versions of games can be done very effectively with CloudFront. We've also added the ability to support live streaming with Windows IIS. This means that you can do smooth streaming with a variable playback rate depending on the user's individual connectivity capabilities. And this lends itself to a much better user experience for those customers that are struggling with perhaps a latency issue or some sort of degradation in their network connectivity at one time. The system will then adapt dynamically to give the exact right bit rate to give them the optimal user experience. I'm going to talk a little bit later about our support for dynamic content, but just one note on the price classes there. You will know that our content distribution network charges differently depending on which region the data is actually being pulled from. With price classes, what we're saying is that we're giving you the ability to switch off the distribution of that content from certain regions if you choose not to pay the additional cost for that. Now clearly your user experience will vary depending on how many edge locations you make available, but if it's your choice to only support the less expensive edge locations, that allows you to cut off the more expensive ones, even though it won't affect some of your traffic depending on where your users are distributed throughout the world. Clearly the optimal solution from a user experience point of view is to enable all of the edge locations, which is the default option, which gives us the ability to distribute your content effectively to any customer in any part of the world based on the latency and the best optimal routing that we can provide to them. Let's talk a little bit about Elastic MapReduce. This is our big data solution running Hadoop and Pig. We're now supporting the latest versions. This is quite a step forward in terms of the compatibility and making sure that the configuration is ready for all the latest versions there. You can read about all the specifics on our website in more detail. We've also added the ability to use our largest instances, our largest cluster compute instances, the 8x large, which allows you to process tremendous amounts of data if you wish to use a large number of instances in a cluster. In addition, we've added support for Apache HBase, which gives you the ability to maintain huge amounts of data in your cluster, in your dealings with that in big data, which gives a huge amount of flexibility and ability to process large millions and millions, billions of rows effectively of data on your cluster. All right, CloudWatch, which is our monitoring system. We released this obviously many years back, but we've now enhanced it with some very valuable additional checks, status checks. The first status check I'll talk about is the system reachability check. What this basically does is reports back to you independently of the actual instance about whether the system that the instance is actually hosted in is available to be connected to. This confirms that network traffic is actually getting to the host system. And below that, the second status check that we've provided is an instance reachability check. This goes down to the operating system level and allows you to maintain visibility on whether or not that instance is actually communicating back with the system. What this effectively does is gives you the chance to know if the system itself, AWS, is at fault, if at all the instance isn't reachable, or on an instance level, if the operating system is suffering some kind of degradation in service, something that you can address by either rebooting the machine or fixing something on the patch or an update on your instance itself. Now you'll know from the traditional CloudWatch metrics that we're able to maintain a view on external factors such as the CPU utilization and the disk I/O and so on from that instance. But we at Amazon Web Services aren't able to look into the actual details of your instance itself. So for instance, we're not able to see what's going on with the packages or software that you're running on the instance or the memory being used and so on. So what we've done is we've provided a number of monitoring scripts that you can opt in to run on your instance that would actually export to CloudWatch the details of your memory utilization, swap utilization, disk space utilization on the actual instance itself. If you choose to publish those metrics, which you may want to do to maintain better control or be able to react on, you can publish those metrics to CloudWatch, and then they're maintained and stored in CloudWatch that you can then extract that data retroactively using the APIs and so on. This gives you a tremendous amount of visibility into the actual operations of the instance itself from within the instance. And again, these are opt-in scripts that you can choose to download and use both for Linux and Windows. On the billing side, we've added an ability for you to maintain a view of how much spend is actually being done on the instance and collectively with all of your accounts. What this gives you the chance to do is to set thresholds or certain limits that you can then act on either through a message service like SNS or an email with SES, or actually take an action on yourself. So for instance, you might want to say, if my account exceeds $500 in a particular month, send me an email to let me know. If it exceeds $750 a month, I want you to switch off a certain instance because that's getting too expensive. So this gives you a lot of visibility on how much money you're actually spending live, real-time to the actual spend of that account. In addition, we've added alarm actions. And this is an effective way of actually cutting down on your costs. If you know that your instance is below a certain threshold of, for instance, CPU utilization, and you wish to take an action on that, you can actually opt to have the instance go to standby, not terminate necessarily, but actually stop the instance to save you money. So if you were doing a dev and test environment and you said that if the instance went below 10% CPU utilization for longer than an hour, that machine clearly isn't being used, so let's just shut it down until I need it next. And this can save you a tremendous amount of money if you were to put these alarm actions in on all of your instances. All right, moving on now to our storage service. We were very proud to announce that we had reached our first trillion objects stored in S3. It's an amazing milestone when you think about how many pieces of data and video files, PDFs, pictures, etc. are now being stored on AWS by all of our many, many customers. We had added support for cross-origin resource sharing, which basically gives you the ability to use multiple domains for your website without having any security issues. It'll validate those additional domains in order to make sure that the website respects them in terms of the security of using those multiple domains across multiple domains for your content. We also added the ability for you to point your root domains now at an S3 static website hosting. What this means is that if you've got a website like mysite.com, you can now point that root domain to a static content bucket on S3 and basically host your entire website, if it's static content, on S3 without running a web server itself. Of course, you can still redirect your CNAMEs, www.mysite.com or mail.mysite.com or whatever it is, to the various other websites or traffic handlers that you wish to use, but it means now that you can use your root domain as a backup right down to S3 for static content. So if anything ever goes wrong, you can always redirect the traffic down, if the web server goes down, back down to an S3 bucket, which is highly reliable and highly redundant. As I mentioned before, elastic block storage has come a long way over the last year. We've improved the reliability that people can get out of those EBS volumes by selectively using the new provisioned IOPS volumes. And basically this allows you to specify exactly how many IOPS you wish to provision for that particular volume. We currently support up to 2,000 IOPS per volume. You can then stripe more volumes together to achieve even higher IOPS, some as high as 20,000 IOPS that you can achieve by striping together multiple volumes. In addition, we've added the ability to view the status of those EBS volumes, which gives you the API access to describe the actual status of the volume at any time to know if it's blocked or enabled, and allows you to change that status via the API as well. One of the most requested features we've had on EBS has been the ability to move snapshots between regions. So we now have built that into the console and through the API that you can have those EBS volumes move from one region to the other. This saves a lot of time in order to move snapshots between regions. You used to have to go through a whole process of spinning up an EC2 instance on either side, but we now take care of that all for you, which means that you can move huge amounts of volume and copies back and forth across it. Storage Gateway is a tremendous way for you to add large amounts of very reliable storage to your on-premises IT infrastructure. By running a virtual machine on your on-premises solution, we can actually give a gateway to a huge volume that's then made available in S3. With the new ability to do a cached volume, you can actually keep data that is currently being accessed locally, and you can specify exactly how large you want that local cache to be, but it actually adds huge amounts of storage back in the background with the volumes that are created in S3. You can have those as large as you want with multiple volumes strung together. In addition, in a time of disaster recovery or something goes wrong with your on-premises solution or hardware breaks down, you can spin up an Amazon machine image in EC2 to actually get access to that gateway volume, so that anything you've got stored in your S3 volumes can now be made viewable through a virtual machine in EC2 within just a couple minutes. This represents a tremendous step forward in terms of being able to recover from disasters in the event of something going wrong with your local hardware, and gives you the peace of mind that anything you put in your cached volume will eventually trickle down and store itself in S3 for the long term. As you might have noticed, we've continued to grow our global infrastructure. We've added 15 new edge locations over the last year for a total of 39 now around the world, which again improves the customer experience by delivering cached objects for distribution, for video distribution, static content as well. And this brings a lot of our services much closer to a lot of people around the world. We added a tremendous new region in Australia, Sydney, which was very requested down under, and it's nice to know that that's now being well received and well used. We've also continued to roll out many of our services that were only in some regions by spreading them out to all the other regions around the world. So if you go to our website, you'll be able to see our global infrastructure has continued to grow tremendously. So that's the first section of the presentation. I'm going to now move into go into a little bit more detail about the new services we've added. These are just some of them that we've added in the last year. For instance, DynamoDB. For those of you that are familiar with traditional SQL databases, this is a NoSQL database. It provides incredibly low latency, less than 10 millisecond latency to the data, and is a completely managed service. It's fantastic to know that customers don't have to know about configuring, setting up any of these systems. They can simply start throwing data into DynamoDB, and we will take care of all of the architecture, the configuration needs in terms of increasing the sharding, increasing the distribution of that content through multiple availability zones as well for very reliable storage of your data. In addition, we've added support for elastic MapReduce. So for those of you that are doing large amounts of high volume and high speed data interaction, you can now use EMR with DynamoDB as well. Simple Workflow Service is a managed service that we've put in as well to allow you to orchestrate the distribution of your tasks within AWS. This allows you to focus on the application logic and not have to worry about writing all the workflow code. In terms of orchestrating and coordinating a lot of actions within the various services like EC2 and RDS and so on, all of these services are now taken care of by a very manageable service, which you don't have to actually worry about the logistics underneath the covers. Of course, the service is distributed amongst all of our availability zones, so it's highly available and highly reliable, meaning that you can just throw those tasks at it and let them take care of themselves without having to worry about maintaining control of all the systems that actually execute the tasks themselves. Cloud Search was our addition to the search market. This is actually the same technology that powers Amazon A9 and Amazon.com. It allows you once again to take advantage of our ability to run these IT systems without you having to worry about the configuration and the setup. Again, it's on a pay-as-you-go model, so the costs are incredibly low, and allows you to put all of your data that you want searchable into an in-memory database that will be maintained and controlled by AWS for you. It's simply a matter of uploading the indexes or uploading the data and allowing us to maintain control of that for you. In terms of long-term storage, we're very excited to have announced Amazon Glacier last year. This is effectively useful for data that you don't need access to on a frequent basis. In fact, you may never need access to it, but you want to know that it's very reliably stored. The price is the most amazing part of it, down to 1 cent per gig per month, which is an incredible savings even on the existing system of S3. If you think about the reliability and the durability that we've provided with S3, 11 nines of durability, we're able to offer this in terms of this very low price by giving you access to the system to place your data in, but assuming that you're not going to be accessing the data very often. So if you can think of several sections of your data that now just simply need to be archived for the long term, you can specify a policy in S3 that would take that data, let's say data that hasn't been accessed for over a year, and move it down to Amazon Glacier, where the price will be dramatically reduced. And if you need access to that data, you can request it and expect to get it back available within 2 to 3 hours. So if that time period isn't a problem in terms of retrieving archived data, this is a very, very effective way of storing long-term storage for archiving and long-term backup. Data pipeline is an ability that we've provided for customers to orchestrate shifting of data between different data sources on a repeatable basis. If you have a large run that you want to do on, for instance, on logs every week from a certain bucket in S3, you can orchestrate a pipeline using data pipeline to actually execute that command on a regular basis. So you might say, pull the data out of Amazon S3, run it through Elastic MapReduce, process the results and place them in RDS, and then send me an email to tell me that the whole thing is done. So this is a very effective way of setting up something that you don't want to have to orchestrate and run manually every time. You can just reliably have it executed on a regular time schedule. You can also integrate this with your on-premises solutions. So if you have data or logs that are stored locally on your systems and you want to pull them into the cloud on a regular basis, process them, and then store them again, you can do that as well. Redshift is our entry into the data warehouse market. We announced this just last December in Vegas at our reInvent show. Effectively, we've listened to customers very carefully and provided a solution that is 10 times more effective, 10 times more performing at a tenth of the price. In fact, we can get the price down now to as low as $1,000 per terabyte per year, stored in a columnar database that you can use for very, very fast petabyte scale data access. Of course, we integrated this with all our existing data solutions like S3, RDS, DynamoDB, and the data pipeline which I was just describing, and gives you the ability to pay for all this on a pay-as-you-go model. Very effective. Another exciting advance we've had in the media industry is the ability to offer you Elastic Transcoder. This service allows you to take existing data content, media content that you might have stored in S3, and convert it to any one of a number of presets or manually configured configurations that you might want to set up for your different device outputs for different end customers. So for instance, you might take a high-resolution original video and convert it to one that's suitable for viewing on an iPhone, an iPad, an Android device, or a Kindle device. And by setting this up in what we call a pipeline, a transfer pipeline, you can actually have this video transcoding happen repeatedly. Now, of course, all of this is a completely managed service, meaning that you don't have to set up any of the infrastructure underneath. You don't have to worry about any of the licenses. You don't have to worry about any of the scaling that's required. So it doesn't matter how many instances of video you need converted or transcoded at any one time. You can just throw that at the service programmatically and let us take care of all the rest. The best part about it is the pricing. We've made it available on a per minute basis. So you pay per minute for either standard definition or high definition video, and you only pay for the minutes that you actually convert. We've also offered a free usage tier so you can try it out, which offers you the ability to convert 20 minutes of video just to check out the system and make sure that the conversion is happening in the right format for you as well. Now, just to get a little bit more detail about some of the EC2 instances we've added, we've now released our second generation, which we call the M3 class of family of instances, seeing a tremendous drop in price on the M1 instances as well at the same time. We also offer a very high memory cluster instance called the CR1. This offers a staggering 244 gigabits of RAM, 88 ECUs, that stands for EC2 compute units. Bear in mind that one ECU, one Elastic EC2 compute unit, is roughly equivalent to a 1 gigahertz Opteron Xeon processor. So 88 ECUs is quite a powerful machine with an addition of two 120 gig SSD drives on board. In terms of use cases where there's a need for a tremendous amount of on-board storage, we've also offered a high storage instance, HS1. This actually offers 24 2-terabyte drives, bringing a total of 48 terabytes on board with 117 gigabits of RAM. So we encourage you to go back and revisit, as I was saying earlier, revisit your architecture in terms of the number of instances that are actually available online now. with this huge variety of instances, it's very often the case that customers can fine-tune their application and their architecture by changing the instance types very easily to more efficient ones or more effective ones from a cost point of view. And by revisiting your architecture, you can often squeeze out a little bit more efficiency in the costs by using the correct instance type for the correct use case. So talking a little bit more about costs, as I've mentioned, we've lowered prices many times over the last 5 years, and I just want to go into a little bit of detail about how you can actually take advantage of this. In terms of EC2, as I was saying, the EC2 price drops are just on the instances. You can use that to your advantage just by re-architecting and revisiting your infrastructure choices. By simply stopping an instance and restarting it on a different size, you can take advantage of those price drops by changing to different instance types. But in fact, if you're using infrastructure right now on any of the machines or instances that are actually part of that price drop, there's nothing you need to do. We will simply lower the cost for you, and your payment at the end of the month will simply be lower just by virtue of the fact that we've dropped those prices. We also reduced the price for data transfer between regions. We found that a lot of customers were moving data frequently between regions, so we were able to drop the prices on that transit, meaning that if you're making database backups or moving data to replicate amongst regions, that's going to cost you a lot less. I want to talk a little bit more about multi-AZ RDS. Talked about this earlier when we said that a database can run either in one availability zone or multiple availability zones. We've now reduced the price. It used to be double. If you were running a database in one AZ and you wanted to make it multi-AZ, the price would be basically twice that price. But we've actually reduced that to encourage customers to try and take advantage of multi-AZ replication as much as possible. If you are running a production database, we highly recommend that you use this multi-AZ feature because it just ensures a lot more reliability and redundancy in your system and make sure that your infrastructure is resilient to any issues that might occur in one availability zone, making your system much more reliable from the outside. So as I said, we've continued to drop prices, and we now can count 25 times since AWS has launched that we've actually dropped those prices. If any of you are new to AWS, you might want to go check out our simple monthly calculator. This is a great tool online that allows you to model the proposed system that you're going to be using in AWS to get a very accurate idea of how much that's actually going to cost you on a monthly basis. In addition, we've added a new tool called the TCO calculator, and I put it there a bit tongue-in-cheek with the non-ownership, but if you're wanting to model the comparison between running your own on-premises solution, buying your own hardware infrastructure, paying for the additional costs of running the power, the cooling, the additional personnel, the data center storage space, and so on, and you want to compare that to what it might cost in the cloud, this is a great tool to do that apples-to-apples comparison. Finally, I'm going to encourage you all to look at cost optimization very carefully. We've added a number of features and tools such as cost allocation tagging that allows you to identify various parts of your infrastructure and actually paint them with various tags virtually online that you can then group all of those instances of a particular type to look at the actual costs that are being allocated to them. So for instance, you might have your dev and test environment all tagged with a specific label and your production system in a separate label so that you can differentiate those costs. We also offered detailed billing reports now that are dumped into an S3 bucket that you designate. If you want to switch this on, it's simply a matter of going to your account online, logging into the billing section, and then asking it to dump those details down into your S3 bucket every month for very, very detailed usage metrics and detail on how you're actually using AWS. Again, CloudWatch offers the ability to shut down instances when they're not being used below a certain threshold of CPU utilization. It's simply a matter of going into CloudWatch and setting up an instance action on that particular metric that you specify. For those of you that are not on support, we would highly encourage you to look into this. We've got a premium support offering that actually offers a trusted advisor. This is a monthly report that will give you heads up on any utilization issues, any wasted resources, any gaping holes in your security. It'll basically scan your whole AWS account and give you advice on how we can help to improve the costs and improve the security. So that's a very worthwhile thing to look into, trusted advisor. Just briefly, I'm going to add a whole bunch of more weight to what I was saying earlier about different solutions. And when you combine all of the things that we've been adding together, all these feature enhancements, you'll see that we're able to handle solutions that really help to solve very typical IT problems in the industry. If you look at backup and recovery, for instance, there's a tremendous amount of value in tying together all of the options such as EBS, S3 with its various policies that can then export content down to Glacier using the different types of databases and so on. So we encourage you to research just how much you can use all these services in combination to actually provide you with a complete backup and recovery solution. In terms of database sharding, I talked earlier about the ability to promote a read replica to a full database, to a full RDS instance. Let me give you an example of how this might be very, very useful. If your database is increasing in size and you're adding more and more data to it to the point that you actually need to start sharding, in other words, splitting up your database into various segments, what you can do now is create read replicas of that full database, promote the read replicas to full versions of RDS, and then cut out or delete the data that you don't want from those individual additional read replicas that you've created. So this is a much smarter idea or much more efficient idea than creating a brand new RDS instance and actually trying to export the data that you do want from the existing database to the new one. Just a pattern or a use case that you can actually consider to more efficiently manage your database. In terms of CloudFront, the ability now to support dynamic content as well as static content means that you can effectively run your entire website with CloudFront as the front end. For static content, as you've traditionally been doing for JPEGs, for CSS files, images, video files, etc., you continue to use CloudFront. For dynamic queries that might be repeatable, you can now cache the results of those queries at the edge, saving you a lot of traffic back to your original instance. A good example is if you have a website that you are running to export the cricket match data. If someone's asking what the cricket score is, the chances are it hasn't changed much in the last 30 seconds, 60 seconds. So why would you want to go back to the original instance and make that query repeatedly, which puts additional headache and traffic on your actual instance, when you can actually cache the result at the edge and make that a much more efficient, effective way of delivering those repeatable queries. In addition, you can have CloudFront redirect traffic to external custom origins. So if you have sources such as ad servers or media servers that are external to AWS, you can also have the traffic redirected there based on the query or based on the request that's actually been made. For those of you that are following the whole trend in big data and elastic MapReduce, we now offer so many more options in terms of the data processing that can handle within EMR, including DynamoDB, S3. We now support Hive as well. So you can do a lot of your processing with a lot of different data sources based on all that content in there. Bear in mind that if you have large amounts of data external to AWS and you want to bring them into the cloud, we have another service called import-export. It's a very successful way of bringing in large amounts of data by physically sending us those drives. If you have large content, media content, and so on, you can actually send us those drives, and we will then import that data into your buckets in S3 and make them available to you online in the cloud. And this can often be a much more effective, fast way of moving data from external the cloud to the cloud. And now, hot off the press, just in the last 24 hours, we have introduced a new service called AWS Opsworks. This is just another example of how fast we're actually innovating in terms of how many times these new features and services are coming out. Basically, Opsworks is a way for you to manage your application by specifying multiple layers of your application, and then within each layer specify a number of instances with particular configurations. So for instance, you might have a layer for your web services, a layer for your load balancing, a layer for your database services. And then each one of those layers can contain instances that are either provisioned or configured by way of chef scripts that you can specify or download publicly available ones. And you can also add and remove instances on those particular layers either by schedule or by load. So it's just a way of managing an application in a much more simple, click way. We encourage you to take a look at this as well online. So I've really blasted a lot of new information, a lot of new details here over the last 50 minutes. One of the best ways to actually track all of this is to watch our blog. We have a very detailed blog that gets updated every few days, aws.typepad.com. It contains a wealth of information on how to get started on some of these new services and feature enhancements. And of course, you can always refer to our website, which keeps track of all these announcements on the What's New section, or the detailed web pages that might have specifics about any of the particular services. So with that, I'm going to turn towards questions. So if you have any questions based on all this, I know I've thrown a lot of information at everyone, a lot of details about a lot of services. If there are any questions I can answer, please submit them. And after that, you'll be able to go into the survey to see about the getting the AWS credits. I think a lot of the questions we've answered already by electronically over online, but if there are any questions in addition, please feel free to send them. We'll also be publishing, I know I've gone through a lot of slides very quickly here, we'll also be publishing the slides onto SlideShare, so that link will be available as well shortly. If any of you are interested in watching some of the content that was released at our user conference last year, reInvent, we'd encourage you to go to the website as well. We've got a YouTube channel there, AWS Web Services, that has a lot of great presentations that you can check on there. So I've got a question here, what are the use cases for Opsworks? Basically, if you have a system that is able to be divided into multiple layers, and you can specify that system by way of a configuration script for each instance. So you might say start off with a basic Linux system, install PHP, install this, that, and the other piece of my source content, and then spin up the instance. You can specify how that instance is created, and then Opsworks would take care of actually deploying that instance layer onto a number of different availability zones, or specifying it for an application. And because an application is made up by multiple layers, by specifying the application in total with those layers and with the instances underneath them, you can automate a lot of that and have it as a very repeatable system. So I've got a question here. How much time does it take to retrieve data from Glacier? Great question. So assuming that the data is already in Glacier, you would then place a request via API or via the console, and you would be notified in approximately 3 to 5 hours that that data has been made available. Effectively, the data is moved from Glacier out into an S3 bucket, and then you can access it once it's available in S3, and after a certain period of time it will be removed from S3, but of course it still remains as an archive, as a backup in Glacier. So the time difference between when you actually make the request to when it's available might be 3 to 5 hours, but because that time is a little bit longer, we're able to charge a lot less. And we're assuming that most of the data that you put into Glacier, you will not want to access it for possibly years or even ever, so it's very rare that you'd want to pull the data out. If you have a need to access the data on a more frequent basis, we would suggest leaving it in S3 or using RRS, our reduced redundancy storage option in RRS in S3 to reduce the price, but that keeps the data available immediately. Of course, for data that's very active and needs to be accessed instantaneously, that would keep it on a live database, something like DynamoDB or an EBS and so on. So the question, another question I got here on Glacier, how is the data submitted to Glacier? Well, there's a number of ways that you can get the data into it. If you use our import-export service, you can actually send us a large, let's say 2 terabyte external drive that we would then load the data up into your S3 bucket. Once it's in S3, you can then opt to, by way of a policy, you can opt to have that data transferred to Glacier on a certain time basis. So you might say, if the data has been in this bucket for longer than a month, I want you to move it to Glacier. That policy then keeps it in Glacier for as long as you want, but it means that you're using S3 as a sort of a way station to move it from your external hard drive into S3 and then into Glacier. Of course, if you already have large amounts of data in S3 today, you can simply specify the policy to move that data into Glacier. Or you might want to use something like DataPipe to actually orchestrate the regular repeated movement of data from various data sources into S3 and then into Glacier. I'm just scanning for a couple more questions here. Another question is, can S3 buckets have the same security groups or policy as an instance have? Well, this is a slightly different model. On an instance, you're really specifying security by way of how many ports are open and what the source of the IP address that can access those instances. In storage, you're specifying it on an object or a bucket level basis about who can have access to that from a user point of view. So if you, for instance, wanted a piece of data that was publicly available, you'd make it available to everyone. If you only wanted to specify a certain number of valid accounts that could have access to those objects or those buckets, you could specify those by way of the actual AWS accounts, or make it available as a token that you would then provide someone to access that data in S3 for a limited period of time. I've got a question here. Is there an API to launch Amazon instances instead of opening the console? Absolutely. You can basically do that a number of ways. One of them is to use the command line interface. You can also use a lot of the API tools that are provided in various languages. If you're familiar with .NET or Java or PHP and so on, you can actually programmatically make those instances begin by selecting the AMI, choosing the region, choosing the availability zone, and so on. So that can be scripted and sent out as a command that can then be executed to start those instances. So obviously when you're starting instances one by one in the console, that's a great way to learn and understand the basic concepts. But anything that you can do in the console, you can also do through the API or through our various SDKs. So I'd encourage you to go to the website and look at the various API tools and the various SDKs that you can use to actually provide all of the functionality that you see on the console. You can actually do programmatically through scripts as well. All right, so I think that's, we have one more question. Let's just bring it up here. Is it the best idea to share static content of an HTTPS site through CloudFront? Yes, absolutely. So we would strongly encourage you to move any and all static content from your web servers into S3 and then make them available by way of a distribution of CloudFront. What this does as well is reduce the load on your web servers, because any time that a traffic request comes from an end user or a website to an instance, that instance has to process that request and send the data back. If that instance no longer has to serve that traffic but can rather offload that to CloudFront, it means that the CloudFront servers can take care of that. So the size and shape of your web servers doesn't need to be quite as big, and you can actually lower the costs like that. All right, so I think with that we'll cut off and we'll answer some more questions online. But I think that's the end of the seminar, of the webinar. Thank you very much for your time and attention. We really appreciate your interest in AWS, and once again, just encourage you to go to our website to learn more. Thank you very much. Goodbye.